Okay. Well, that's good.
Tom, we are live here, so you might want to mute.
Hold on a second. Got it.
All right. Welcome back. We're starting up after lunch here. Tom, come on back in. We'll say hi here. There we go. All right. Welcome back. We're going to start off this afternoon with the session. I'm really excited about it. I know it's kind of weird, but vulnerability scanning, because it's kind of at the heart of what we do after the repository, right? The idea that there needs to be a way to manage all of these components that are being utilized, all these components that are being downloaded, inserted into the applications. So, Tom, have you got your microphone on, Tom?
I do.
Great. Can you give us like a 30-second overview of what you're going to be talking about?
Sure. So basically, what I've noticed is that after folks have IQ Server set up, they have the installation done, the configuration is done, it's running. They have their policies defined, and in defining policies, they've gotten a group together that generally includes developers, includes security, and includes legal, so that all that's in place, and they start scanning. And in some cases, I wouldn't say they're inundated with the results, but in some cases they are. So they're left with really a lot of vulnerabilities there, a lot of issues that they need to deal with, and I see delays. I'm not sure if it's just because they're not sure exactly how to move forward. So really, what I want to cover today is just lay out a 6-step, pretty easy process, at least on paper, that gets folks moving forward, so that they're just not stopping with just having the results of the scans.
All right, great. Thank you. Tom, I'm asking everybody here, where are you physically? Where are you located?
I'm in Maryland. I'm in northern Maryland, about 1 mile from York County, Pennsylvania.
All right, great. And for those of you that are listening, and it looks like the audience is growing, so I'm kind of tap dancing here while people come in after lunch, Tom. I'm going to ask everybody in the YouTube channel that you're watching there in the right-hand column, there is a little chat room. If you wouldn't mind, can you put the town and state or country where you are right now? I think Tom and I both would be interested on how far the reach is going there. And at that, Tom, I will turn it over to you, and I'll see you back in a half hour.
Okay, thanks, Mark. I appreciate it. Well, hello everyone. With that little spiel, the this is pretty much what I was talking about in terms of where folks tend to stumble at, or at least lose some momentum. There's usually a lull. This is just one example of an application scan. There could be many. When you start to look at it from an enterprise perspective across the whole portfolio, there can be hundreds, if not thousands, of policy violations and security violations or security issues that that you need to act on. So just wanted to lay out something that would really move you forward. So what I'm hoping is that after the presentation, you will have a way to move forward, and I'm going to set out some general processes that you can tailor, and then also give you some ideas about how to measure your progress and your success as you move forward. So this is 6-step process, really. Pretty simple. It starts with defining roles and responsibilities. Without roles and responsibility, you can't communicate who has responsibility for doing what in terms of their remediation, who is analyzing the findings, who is responsible for maybe a policy change that's needed, or a waiver, or something else that's needed through the process. So it's nice to right up front have those roles and responsibilities set. Next, review and analyze the findings, and then borrowing from Stephen Covey, begin with the end in mind. That is, set goals, set some high level goals, set some medium level goals, and then really get into defining what the remediation workflows are. What are you actually going to use to mitigate your risk. And then just as important is socializing these plans and promoting the developer adoption. That's where the rubber hits the road. So we really need to bring them all in and work as a team. And then last but not least, measure progress and success. You need to be able to measure it for yourself, but also for those up the food chain. How do we know that you're actually getting value from your investment in vulnerability scanning and using IQ Server, and how are you actually proceeding with that? So starting off with step one, clearly defining the roles and responsibilities. By the time you get to this stage, a lot has already taken place. So you've already identified what we're calling the policy participants in the top of the table there, to where you've brought together folks from legal to discuss and come up with policies related to licensing, as well as security, and then also architecture. So generally, there's a group that includes representatives of all three of those, and including development if that's not part of architecture. So that's done. That's in place. In the integration, you brought in operations. All the servers are set up. LDAP is configured. Everything is ready to go. You've got your scans started. So really, we're down at the bottom piece, down in the lifecycle participants. So that's really what we're talking about: managing the life cycle of applications. And really, remediation is going to be continuous. But when you do the initial set of scans, you are going to have a fairly large set of issues that you need to deal with. So the two that I want to highlight are the lifecycle sponsor and the project owner. So the sponsor really, he's responsible for, excuse me, the sponsor is responsible for socializing the adoption of lifecycle. Generally represents the open source governance within the enterprise, and also risk. The project owner, that is often a software development project lead or tech lead or some other kind of business owner, and they're really going to be responsible for the findings and the waivers and things like that. But as I mentioned before, the developers are really where the rubber hits the road. Those folks that are going to be responsible for selecting non-vulnerable components. They're going to be responsible for actually doing the remediation and mitigation of the findings. So my suggestion is actually to name these folks. Developers, there's going to be a large number of them, but maybe a team list. But particularly the lifecycle sponsor and the project owner. Make it clear who you can turn to in terms of getting answers to questions and different pieces of the process. So the next step is basically reviewing and analyzing the findings that are there, taking all those reports and kind of wading through. And really, what I want to point out is that at the end of the day, the findings, they have to be actionable. That developers, they shouldn't be in the job of validating and doing research unless it's absolutely necessary or things aren't clear. But they really should be there for mediation and not for validation. And one of the things that is important to understand is that the findings that you're looking at, really, those are set based on your organizational goals, the life cycle of the application that you're looking at, and the policy decisions that you've made. And don't be afraid to adjust policies if necessary. One size does not fit all. We ship the IQ Server product with a set of reference policies, but that doesn't mean that it's going to fit everyone. And really the key is to figure out what the signal is versus the noise. If through this process, which is iterative and continuous, you find out that you're ignoring large sets of findings for whatever reason, really that tells me that you need to take a look at adjusting your policies, because you're getting a lot more noise than you are signal. And it's the signal piece that you really want to get down to the developers in an actionable form so that they can remediate. So as you're looking through and you're doing the analysis on the findings, a couple things to keep in mind are the types of issues that you're dealing with. Are they configuration related? So are you looking at components that are configured to be insecure? So are they vulnerable to direct exploits? Are they functional type issues to where there's a function being called, for example, integer validation? That's an issue. Or are they really user input? Is it cross-site scripting? Is it SQL injection? Is it something that's simple as test code or sample code was left in an application and it's at a certain stage of the life cycle where it just shouldn't be there? Or are these operational to where there are runtime issues that affect the runtime of applications? That's all going to basically drive the information that is provided to developers so that they can remediate and not validate. And one thing to understand is that really when you're talking about the security issues in particular, the best case scenario is that this is technical debt. You've got a framework, maybe it's an older framework or set of components that you're using, and you know that well, for it may be coming to the end of its life cycle. So we need to move, but right now we don't want to. That really is just technical debt, and you can track that. The worst case scenario is that you have an exploitable vulnerability running in an application. So keeping those two things in mind really helps you prioritize the remediation. That goes right into the second bullet there, identifying the immediacy of the fix. Combination of not just the vulnerability score, but also the threat analysis. What a component may have a high vulnerability score, but it may not represent that much of a threat in the particular situation or, that you have within your application or applications. So I highlight the third bullet because that's really where it becomes actionable. You've got to pipe these issues and findings into your SDLC tool. For example, for Jira, they've got to be able to. The developers have to be able to have those in their hands to make decisions. They use the descriptions of the findings in Jira or whatever tool that you're using, and that really sets the stage for remediation. So shifting gears a little bit, so set goals. Again, start with the end in mind. So how do you envision your applications and your risk posture at some point down the road? What is your goal, and work back from there. So these are just not these aren't necessarily best practices. These are just examples that I'm throwing out there. For example, beginning with the end in mind, not having any components with CVSS score greater than 5 in operation as of a certain date. So, and then working back from there. Having your architectural blacklist, which components, which frameworks do we not want to use? They don't have any role in the organization at a certain time. Having that defined, putting that in writing. Moving down into policy type things. Warn on builds and release for CVSS greater than 5 until a certain date, and then fail after that date, and communicate that to the development team and all of the stakeholders that these are our goals. Another one, all current issues and project backlogs and ready for sprint planning. If you don't have these findings in the hands of the development teams, be it the Scrum Masters, be it the team members themselves, then they're not going to be able to prioritize. They're not going to get into the sprints, and they're not going to be remediated. And then finally, have a process in place for any new issues. So we're talking about, this isn't a one-time process or situation. Remediation has to start. So really just trying to kind of kickstart and move forward. But really, when you start talking about greenfields project versus brownfields, then you're going to have a process in place for that takes care of continuous scanning and continuous remediation throughout the life cycle. That's where your efficiency is going to be in place. So have that documented, have that defined and documented that we're going to have this in place by a certain date. Have that milestone out there. And again, these goals can change through time. It's your process. It's your environment. if they are not working for you, for example, then maybe you decide that, well, maybe we were too ambitious. Maybe we're not going to do CVSS greater than 5. Maybe it's 6. Maybe it's a 7. Maybe it's an 8. Based on uh, your ability to define your risk tolerance, then really you set your goals, based on that. So again, it's all about managing risk. Now, switching gears to defining remediation workflows. I like this. I like this definition. So risk management is a process of, one, identifying vulnerabilities and threats. So you've pretty much done that. That was a starting place that we had. And then two, deciding what action or actions will reduce those risks to an acceptable level. So that's the remediation workflows. That's the heart of it. And really, the bottom line that I've underlined there is that the objective is to reduce the risk to an acceptable level, and that's where you set your goals and tailor your policies. So this is an example workflow for security issue remediation, and I just throw this out to basically say, okay, this is something that you could take and tailor. It may not fit yours. It's not a one size fits all, but something that you can take and then publish and share with all the stakeholders. So pretty typical as you would suspect. So, first question is is there a version upgrade possible? Is there a component that is not vulnerable or is less vulnerable? If yes, then this is great. Then you've got this really easy process. You upgrade, you refactor, and you're done. So we know that that's not exactly a simple process, but that is the most direct way of getting to your end state. But so what happens if you need to use a different, can use a different component? If you can't, well, then a little bit more research is done. Hopefully, it's done before it reaches developers. Is it exploitable? If it is exploitable, can it be mitigated? Are there some things that can be done to mitigate the risk? If it's not exploitable, then you can handle it through a variety of different ways, and I'll get into that in terms of waivers, or you can use labels, or you can do status changes, a variety of things to get you to done and basically say, okay, we've remediated this security issue. If you can't mitigate, well, then that really is when you get into your risk management process, and you have to have discussions about, okay, so are we willing to accept this risk? In some cases, there's no alternative to that, and you mark the issue as acknowledged. We acknowledge that there's a risk there, but we can't mitigate that. We just have to accept it at this time. So similarly, for licenses, here's an example process that you can use. Starting out the same way, can you change the component version to one that has a more favorable, more desirable license? If yes, then you have a pretty straightforward path forward to getting to done. If not, is there another component that is available? If there isn't, then again, internal risk management process is brought into play. There's some discussions about how to do that, and I'll show a couple things about issues with licenses, and maybe there are multiple licenses or the wrong one is shown. But eventually, you'll have to come to a decision about whether or not it's acceptable, or you just simply disallow the use of the component because you can't accept the risk that particular license presents. So, one of the things to consider is when you're analyzing licenses, is the component multi-license? So, if so, maybe it's a matter of selecting the correct license, or basically understanding what is driving the multiple licenses. Maybe it can be used in certain circumstances, and in others it can't be. There's a risk to using it in certain circumstances. So in IQ Server, there's a way of addressing that. You can basically select the the license that applies to that, and that's a way of mitigating or addressing the risk. And I stick in there, add a comment, because it's always good to document why you chose to handle remediation in a certain way. So there can be situations where the license is just not correct, and you've determined that you need to override the license that's there. It's either not declared, or there's some other something else comes into play to where you need to override it. So there's an ability to do that, but ultimately the idea is that you are making a conscious decision to accept the risk by changing some factor related to the license for that particular component. So at the end of the day, you may be left with a situation where there there isn't a fix. Not all issues need to be fixed. I mean, for example, the cost may not justify uh, the uh, the remediation. And that may be from the fact that it's an application that has a limited product life, or there's a low risk of exploit, or it's just simply not applicable for one reason or another. So a waiver could be issued for that particular component. If a waiver is needed, then I suggest that you provide pretty specific information related to the waiver. For example, what application, and particularly the ID of the application that it applies to, what policy it's violating, and the actual CVE that's involved. And then also, most importantly, why you're waiving it. What's the justification for the waiver? So one of the things that we suggest is that really policies need to be used sparingly. You don't want to get into a habit of waiving all present and future issues for a particular component. So now the rule of thumb is that really you need to think twice. Security issues should almost never be waived. There are alternatives to that which involve management of the components and the risk, as opposed to just simply waiving. For example, the use of status and labels. So status and labels are really just adding metadata to a component. And then by adding that, you're able to tweak your policy a little bit, make some modifications to exclude certain components from those policies, but for very good reasons. For example, right here, status is changed to not applicable. Why? Well, because it's not used in a way that presents a risk. So that's a perfectly good way of remediating or handling an issue without issuing a waiver. Component labels are very good for creating architectural exceptions. So you can create blacklists. You can create and track components that you want to investigate further. You're not sure exactly how you want to handle the remediation, but you don't want to waive them. You don't want to lose them as you do scans in the future. You want them to pop up as findings, but you don't want to treat them, put them into the full remediation process at that particular time. So the fifth step is really socializing the plans and promoting adoption among the whole community, particularly among the developers. So from the very beginning, in terms of defining policy, defining for both license and for security, and for the operational side, it really has been a collaborative effort to move DevSecOps forward. So we need to recognize that the priorities of different groups are different, but like all security, risk management is everyone's job. So everyone has a part, and the more that the plans are communicated and socialized, then the more buy-in and adoption there is throughout the DevSecOps community within the enterprise. So I bring up that first bullet there. Support and guide, don't scan and scold. So I came out of a scan and scold environment, and it was one to where the the scans were done at the tail end of process of the life cycle, and I should say probably it was based on frequency as opposed to the progress through a sprint or sprint release. Um, and the development team did not have the ability to create their own scans. We wanted scans for every sprint, multiple times during the sprint if necessary, but that wasn't possible. So we would get these reports at periodically, and they might be 2 or 3 sprints old. And of course, everyone was CC'd on it, explaining how many vulnerabilities we had, and it was just not a good process. So I'm sensitive to that, and I'm particularly sensitive to scans containing information which developers really just can't. Um, they can't remediate. They can't deal with. It's out of their hands, and so really it needs the whole organization, the whole DevSecOps organization needs to provide the support and guidance as opposed to scan and scold. So what am I suggesting? I'll set up a wiki page or a Confluence page or some mechanism of choice to communicate the things that we've talked about, to communicate goals, very very clearly with the timeframes, to communicate expectations, to communicate workflows, and to communicate how these policy changes and waivers occur. And I'll throw in a little bit. If you have existing quality management systems and other mechanisms, consider incorporating these workflows and processes into those. Don't make if your governance is based on ISO 9001 or 27000 or CMMI or some other set of management systems or processes, then don't have the remediation process to live in a vacuum. Incorporate those all together so that the DevSecOps community has a consistent set of operating procedures and processes to work on. So I'll quickly kind of go into the last step, which is measure progress and success. So there's a variety of
All right, Tom, sorry, you want to jump in? You got about 2 minutes?
Got it. No problem. There's a variety of mechanisms within IQ Server to allow you to measure your progress and success. For example, right on the main screen of for reports, you can see the number of issues across your stages. So it's a really nice way of getting a snapshot of doing that. So through time, you should be able to see a reverse trend to where your builds and your stages have less violations than your releases, and that's because your remediation process is working. Again, from the dashboard, same thing. You get a nice view into your applications at various stages of the life cycle, and you can see risk and you can start to see trends. But the one thing I particularly want to bring up is the use of success metrics within IQ Server. Some really good information there, particularly through time as you build up. You can start to take a look at things like mean time to resolution, by month. So you can really start to see some good progress. And as you do this and you share this with the team, then they're going to say, okay, what our remediation efforts are working. We're seeing the number of violations go down, and we're really making a lot of good progress. Some other things that are there are really get a good snapshot through success metrics of the components used across the applications, but then I really like the last one, components with the most policy violations. And that starts to help you to look at architectural issues and really start to prioritize and focus your remediation efforts. And the last thing I want to mention is that check out the IQ Server documentation for the REST APIs and for webhooks. There's a lot of really good information there. There's not time to go into that, but there's really good ways of integrating, particularly if you're trying to integrate your progress and metrics, your success reporting into other applications. So with that, I'm hoping that I've given you a path forward, that you're not stuck or stumbling over remediation, and that I've given you some ideas about how to tailor these processes. And thank you very much for your time. I appreciate your interest.
Oh, thank you, Tom. There's a lot of information. There was a very dense session. For those of you that want to follow up here, Tom will be in the Slack room after this. You can go check the Slack channel. And then also, Tom, if you would please, while you're in Slack, upload the slide deck so people can have direct access to the information you got here.
Sure.
All right. Thank you so much. Appreciate it. Arseny, how are you?
Hi, Mark. Doing pretty well.
I'm just thank you for coming off vacation.
No problem.
Where are you physically today? Where are you?
I'm in Antalya, Turkey.
Wow, very nice. So what time is it?
It is about 9 p.m.
9 p.m. All right. Well, thank you so much. I know that you had to cut some time out of your vacation here, but very much appreciated. Sure. Can you give us a quick overview of what you're going to cover?
So I'd like to talk about CICD pipelines in sort of the DevOps environments and how the Nexus platform fits into them. What are the best practices for building those CI/CD pipelines, and really how Sonatype assists you in making the best value of our products in that fashion,
Awesome.
fashion.
Thank you. So I'll let you share your screen so we can get the slide deck going and do a brief introduction of yourself so people know what you're working on here, and then we'll go.
All right.
How long have you been with Sonatype?
Not very long. Started in April.
That's good. That's good. All right. You're doing good. I'll be in the background if you need some help.
All right. My name's Arseny Jurgensen. I'm a customer success engineer on Sonatype. And as I said, I haven't been with Sonatype very long, but really passionate about DevOps and DevOps approaches to developing software. So that's what I'd like to talk about today. So just starting from very basic. So as we're starting to develop software, we generally, if you use the agile approach, you have user stories that you define, that you use agile processes to develop, and the user stories have their own life cycle, and I think that can be a whole separate set of talks. But this is generally the starting point for your CI/CD pipeline, whether you're using Kanban, Scrum, or so on. You usually have some kind of a tool that will let you sort of manage that complexity, be it Jira, GitHub projects, Trello, AgileCraft, whichever one of the tools you use, that can be used as a trigger for your CI/CD pipeline. What you can, an interesting thing you can do as well with these tools is you can, as you change the status of your user stories, sort of from the backlog to doing to completed, you can perform actions on those triggers. So an interesting thing that I've seen some of our customers do is generate in development environments based on those user stories. So as a developer begins working on a particular feature, they move a user story change the status in one of these tools, and that generates the development environment for them. and takes a pre-developed CI/CD pipeline and makes all of these connections to all of these CI/CD tools. It can also generate branches on your source control management. So in GitHub or in Bitbucket, you can generate the feature branch and so on and so on. So that's one of the sort of the beginning of your pipeline. You can do a use the status change of the user stories as the trigger, or you can use the either commit or a pull request into your source control management tool. So taking it, so once you have done that, once you have done some kind of development, you commit to your source control management. Generally, during the build process, we're going to start pulling in third-party components into your application. So developers have the ability to make those decisions. They decide which libraries they're going to use and which components, which versions they're going to be pulling into the software. And at the end of the build process, obviously, there's a deployable artifact that gets deployed. So what Sonatype does is we take a look at these third-party components. When those components, when those open source components are used, there's inherent risks with them, with using those components. Some of them have vulnerabilities. Some of the vulnerabilities have not been discovered when the component was built into your software. There are licensing risks that so some of the sessions earlier talked about those. And there's also organizational risk. As your organization can make some kind of decisions at organizational levels to not use or to use particular set of components. So all of those are risks that propagate from your source control into your deployable artifacts. So what our tools do is they take the approach of shifting left, allowing the developers to make the right choices, not do so as Tom mentioned, not take the scan and punish approach, but perform the scanning and evaluation as early as possible into your lifecycle development process, software development lifecycle process. So one of the ways that Sonatype does this is the integration with the developer IDE, Nexus IQ Server IDE integration. And so at the bottom, I have a picture that shows a sample of how this is done in Eclipse. It allows developers, before they commit to source control, allows them to examine their software and take a look at the components that they're using. And sort of make the right decisions early in the process. It gives them the capability to adjust which components they use, which versions they use, and catch those problems before they get to the security folks, before the application is long in the development cycle, before it's been developed for a month. So they can quickly make those evaluations and make those decisions early. So this is really the approach you want to take with all of your scanning with CI/CD pipelines, right? You want to shift as much of the burden further left, earlier into the process, so the problems are fixed earlier. At the bottom there, I have a link to shifting left and the benefits of shifting left, not just for scanning, but for testing as well. I think it's a great article. You should check it out. And the IQ Server IDE integration article as well. That's also very useful. So here's an example of how this looks in Eclipse. We have the components listed on the left, and then we have different threat levels for the policies that you have set up. And then at the bottom, you see the same chart that was that I showed earlier. And the developers can essentially just click the version that they want to be using that does not have as many security alerts, and just click migrate, and it will perform the migration in their code. It will adjust their files to use the different versions of a component. So another interesting concept is trust by verify. So we give it's a good idea to give developers the power to make those changes, but at the same time we want to make sure that nobody's perfect and the mistakes are going to be made, and some of the components are still going to get in. Trust by but verify concept is allowing giving the power to developers, but also verifying that the right decisions are made. So that's where static code analysis comes in. That's looking at the source control and analyzing the code itself, the files. Some of the tools that do this pretty well are SonarQube, HP Fortify, and there are other static code analysis scanners. So then later on in the build process, so once the analysis passes, once that feedback is given back to the developers, the build process starts. And I sort of use just the build process box. It's obviously any build process can become pretty complicated, and it really depends on your application. But during the build process, that's when these components are pulled into your software. So Nexus Firewall allows you to configure which components allows you to enforce the policies that your organization set up and prevent bad components from getting into your organization, prevent them from getting into your software. The Nexus Firewall is powered by IQ Server, which as the components are pulled into the software, we will do a hash of the actual file itself. Look at that hash and compare it to our service. Essentially, we do the research on the components, and we just look at that. We compare the hashes, whether the component that's coming in is what it's, first of all, what it says it is, that there are no extra code or files in there, and that everything looks kosher. Once the build process completes, we generate the artifact, and any components that were identified to be bad are quarantined, and then either the operations team or the security team can take a look at those and decide what to do with them, whether they are indeed against policy, or whether they can be waivers can be applied to allow them to continue into our CI/CD pipeline. So so here I sort of redrew the diagram, and I wanted to show the whole CI/CD pipeline, going from the user stories to the Nexus IQ Server ID integration to source control to our static code analysis to our build process. So from Nexus Firewall prevents the bad components from getting in from third-party repositories. Nexus Repository Manager allows you to configure either proxy repositories or actual hosted repositories that you own on site, that can be leveraged during the build process. So I simplified the different environments here. So I'm just showing the non-production environment and the production environment. In a lot of the cases, you might set up more than 2 environments. You might have a QA environment, a testing environment, and so on and so on. But the concept is going to be very similar. So as you build your artifact, you pull in through the proxy, through the Nexus Repository Manager, the proxy repository that you set up. You pull in external components. You analyze them, that they're allowed to be used in the organization, that there are no security vulnerabilities, or the security vulnerabilities that do exist are minor enough and acceptable to use. Once that artifact is generated, it can be pushed to the non-prod repository. Once there, we sort of move towards the next stage in our CI/CD pipeline. We take a look at artifact analysis. So that is once the artifact is built, we want to look at the configuration of that artifact. So some of that is done by tools like Twistlock if you're using containerized applications, and Sonatype also allows you to take a look at your build artifacts. So be it jars or Docker images. Nexus Lifecycle application scanning allows you to take a look, decompose your application, and to take a look what's actually inside of it. Earlier in the process, during static code analysis, we might have looked at what was being pulled in with Nexus Firewall, but application scanning actually goes back to the trust but verifies bit of it. If different components went around the process, if the developers downloaded a particular artifact onto their laptop and then loaded it into got around your CI/CD pipeline and loaded it into your application as part of the application, the Nexus lifecycle application scanning will help you catch all of that. It will decompose the jars, it will decompose the Docker images, and see which open source components are actually being used there. So the next step is generally penetration testing. Once the artifact has been generated, it gets deployed to your non-prod environment, or one of the multiple environments that you might have. But in this case, for simplicity's sake, we're looking at the non-prod environment. There you can perform penetration testing with tools like OWASP Zap. You can do your integration testing, functional and smoke testing, and performance testing, and so on and so on. So all of those things on the right: integration testing, functional and smoke testing, performance testing. I have them in different color because generally those will be heavily dependent on the application that you're building. They will differ from application to application. But a lot of the most of the of the other stages in your CI/CD pipeline are going to be pretty similar, going from application to application. As long as you're using the same technology stack, and even in a lot of the cases, even going through Java to Python, the tools that you're going to be using for static code analysis and artifact analysis are going to be very similar. So what we've seen a lot of folks do is, or actually a good idea to do this, and some of more mature folks have done this, is templatize your CI/CD pipeline. So once you have, and I sort of alluded to this earlier, when you change a story, when you start developing on a new feature branch, you can generate the development environment for your developers based on a template that has been written previously, that connects all of these tools, connects source control to static code analysis, to build process, to artifact analysis, to penetration testing. So it sort of generates this top CI/CD pipeline for them and connects all of the dots. This really allows, sort of speeds up the development process, where the developers don't have to go into those tools and figure out how they work. They don't have to become sort of minor experts in them by figuring out how to configure webhooks, how to generate projects in each one of these different tools. It sort of gives them a sort of a quick start for developing inside of your organization. So these templates, what's really interesting with them, depending on the tool that you use for your pipeline automation, and so I have some examples actually listed in top right. It might be Jenkins, Bamboo, GitLab, or TeamCity. You can version control your CI/CD pipeline. You can take it and deploy, push it into version control within your organization, and hand that out to your developers as they start developing the new software if they're making a move towards CI/CD pipeline. Sort of having this uniform environment is not just beneficial for jumpstart purposes, but it's also very helpful for your security teams or your testing teams or your QA. It allows them a uniform way to enforce and make sure that different particular things, the things that they worry about, are being completed within the development process before it goes towards deployment. So in a lot of cases, there's hesitance to implement CI/CD and DevOps at larger enterprises because of those concerns. There are certain processes in place that people are hesitant to change because they're not sure how the particular verification is going to happen in this new automated world, right? If we have a CI/CD pipeline, how do we know that all of these checks have been run? How do we replace those manual processes of actually going through and making sure all of those checkboxes have been checked? So having a templatized CI/CD pipeline that can be leveraged over and over again really helps with that, because from the development team to the development team, InfoSec folks can be sure that the development process is relatively same. The deployment and the build, scan, and deploy process is similar, and allows them to have input into that process. It allows them to configure the SonarQube analysis in static code analysis. It allows them to configure which open source components get into the organization through Nexus Firewall. So the shifting left principle applies across this whole CI/CD pipeline. As much work as possible can be shifted left, and not be loaded onto the InfoSec team and the QA team. So another piece that's missing from this diagram, but it's very, very important, is that during each one of these stages, from static code to build, artifact analysis, and so on, there is a feedback loop going back to the developers. And that's really important. Being able to fail fast and to figure out what's going wrong before sort of getting to the end stage, and allowing for quick improvement and sort of really supporting the agile development practices. So another piece that I want to talk about is the non-prod and prod. Once all the performance testing is done, the artifact can be tagged to say, okay, all of the tests have been passed, and then we can do a deployment to production. Nexus repository staging has been released recently, and I provided a link to at the bottom that helps you assist you in implementing this into your organization. So it does tagging on your build artifacts to mark them that they have been that they passed your build and deployment process. So link is on the bottom. More information is there. What a lot of the customers have done before this feature was released is they might actually set up completely separate different environments for non-prod and production. So there can be a separate Nexus repository manager for non-prod and a separate one for production. And through your CI/CD pipeline, you can deploy your artifact sort of without rebuilding the artifact. You can copy it from. You can build it, push it to non-prod. Once your scanning is complete, you take this artifact and without rebuilding it, you push it to the production environment. And that's really ensures that that your supply chain have not been broken, that nothing have been changed, nothing had been added to the artifact once all the security and scanning testing was completed. And the additional benefit is it speeds up your pipeline. You do not have to rebuild it. So for larger projects that might where the build might take hours, you don't have to perform this build again. You just take the artifact and push it to a different place, or you use our the staging feature to tag it, saying that it has passed. So in addition to templatizing the CI/CD pipeline, another approach is templatizing the development environments, using infrastructure as code to generate the deployment environments. So if you are using containerized applications, if you're building containerized applications and you use a platform that helps you manage that complexity of scheduling those containers, making sure they're up, load balancing them, and so on and so on. You can templatize the actual deployment environment in those platforms, and version control those as well. So as part of your CI/CD pipeline, when you start that development on a new feature branch, you can generate an environment from a template that is used just for that feature branch. So you can do penetration testing, integration testing, functional smoke testing, and so on, and performance testing in that environment for that feature branch. And once those tests, all of those tests have been completed, that environment can be destroyed. But the artifact is kept in Nexus Repository Manager, and the testing results are kept as well. So this allows you to do on-demand environment creation and testing. So it also allows you to do parallel testing. So without having you no longer have to reserve a testing environment. You do not have to have a bunch of servers that might be sitting empty and not being used if nobody's doing a build or if nobody's doing testing. It allows you to leverage, if your organization is using the cloud, you can spin up all of those test environments basically on demand, and you can speed up your CI/CD pipeline by running some of these tests in parallel. So you might have a different environment for penetration testing, a different one for integration testing, functional, and so on. Run those in parallel, summarize the results, and once all of those are complete, tag the artifact with saying that all of those tests have been completed, and the next step is to push it into the production environment. So this is the CI/CD pipeline with Sonatype and Nexus platform. This is my presentation.
Very nice. Thank you. Especially that last diagram. I took a screen cap of that. Very nicely done. Thank you. So let me make sure I've got everything going here for you. Just to say there you go. I'm impressed. I'm impressed because, again, even though we deal with this every day, when you see it put into a presentation like this and you see the capability of what's going to happen, it's very, very impressive. So, Arseny, from the presentation that you just did, what's the most thing do you think people should pay attention to in that presentation?
I really think the important bits are the sort of the best practices. Avoiding blindly automating what they're currently doing, sort of replicating the current processes, and really trying to continuously improve them. Using these new tools that are being used now, and the tools that the Nexus Sonatype releases, allows folks to sort of to change how they do things. So we should try to avoid sort of doing things differently, but really try to figure out what the best practices are using particular tools, and what are the best practices for building CI/CD pipelines, and sort of try to follow those and adapt our build practices towards that. So I think that's the most important part.
Excellent. Thank you so much. I appreciate you taking time out late at night in Turkey. Very much appreciate it. If you would jump over to the Slack room real quick, people will have some questions for you. Plus, you can upload your slide deck so that they can download that.
Yep, I'll definitely do that.
Thank you so much. I see myself in slow motion on your screen. There we go. For everybody that is here, thank you for sticking with us for the afternoon. Something interesting is happening on the other channel that is going on right now. James Wickett and Helen Beal and Derek Weeks are actually doing a live analysis of a report that Derek has put together as far as the DevSecOps chain. So if you would, for the 23 of you that are here right now, if you would, please go back to Schedule and click on Helen's session, and that will move you directly into the discussion so that you can hear. Like I said, James Wickett is there. I'm looking at the screen right now because I'm going to walk over and partake in that. So James Wickett, Helen Bill, Derek Weeks, and I are going to discuss some of the software supply chain report. So please, I'm going to shut this one down. We're done here at this channel, and I'd like to see you over in the other one. Thanks.